Welcome back, everyone. I wanted to go over what I would call double chain rule with you, which is where you have a composite function inside of a composite function. And it plays the same way that chain rule does. Remember that chain rule is the derivative of the outside function, keeping the inside function the same, and then timesing it by the derivative of the inside function. Double chain rule, triple chain rule, quadruple chain rule is essentially the same thing. And if you make the lists like I did in the last video, it can help you organize your thoughts a little bit and help you discern what's outside, what's inside. Did I forget something, or am I doing this right? So if I look at the first one, my mild example here, we have three functions. We have e to the power of something on the outside. Inside that, we have sine with an input. And inside that, we have this 2x. So outermost, we have e to the power of something. Inside that, we have our sine of something. And inside that, we have this 2x. So let's just take the derivatives. The derivative of e to the something is e to the something. Not bad. Derivative of sine of something is cosine of something. Derivative of 2x is 2, so we're going to combine all of these together. I'm bringing the 2 out in front because it's going to act more like a coefficient now. So 2 times, and we can do this cosine next. Inside the cosine would be the 2x. And then we have this e to the power of something, and that is going to be what we started with, that initial power, sine of 2x. And if you want to, I kind of got a little ahead of myself with these parentheses. You don't need these extra set of parentheses here. So it's just 2 cosine of 2x times e to the sine of 2x. And the order really doesn't matter because it's multiplication. But as you can see, like if I used the cosine, I used the regular version of the inside of that. If I use the e to the x, I use the regular with the regular inside of it. So I'm constantly using the left side once I use something on the right. So let's try something a little bit spicier, shall we? We still have three parts. In this function here, we have the natural log. We have the natural log of something. We have 2 tangent of something, and then we have 3x squared. So like before, we're going to take the derivative of each part and see what happens. The derivative of the natural log of something is 1 over that something. The derivative of 2 tangent of something is 2 secant squared of that something. And the derivative of 3x squared is 6x. So I'm going to line these up, and we're going to see something kind of strange happen. So we have the first part, which is this 1 over, and again, I'm going to go to the left now. I have this 2 tangent of 3x squared. Multiply that by 2 secant squared of 3x squared. And then we're going to multiply that by 6x. Well, some weirdness does kind of happen here because of trig. In your pre-calculus class, you probably spent a lot of time with trig identities and such and simplifying them. And that can happen here. So the 2's will cancel, that's nice. And then I'm going to write the tangent and the secant in terms of sines and cosines. Because the inputs of them, the insides of them are the same, we might be able to do some simplification there. So the tangent would be 1 over tangent is cosine of this 3x squared over sine of this 3x squared times secant squared is 1 over cosine, so that would be 1 over cosine squared of 3x squared. And we're going to multiply that by 6x over 1. Now we can see that this cosine and one of these cosines will cancel out. And then if we want to simplify everything out, we just multiply straight across, and then we can bring the sine up by making that a cosecant. We can bring the cosine up by making that a secant. So this is going to end up being 6x times the cosecant of 3x squared times the secant of 3x squared. So technically, while this yes would be the answer, it's not completely simplified, so depending on who your teacher is or your professor is, might determine whether or not you get like full credit for that question or not. I'm pretty lenient with my kiddos, only because I'm mainly evaluating their calculus and not their algebra. But again, depending on who you have, they might be a little bit more picky, or if you're taking like the AP exam, they might be a little bit more picky. So that's it for my spicy examples, my double chain rule here. Good luck with any practice with this, and I'll see you in the next video.